Hey, we're doing some algebra, and we're going to be looking at the complex numbers. Okay, so this first part here is going to be an introduction and looking at the big picture. Let's take a look at this equation here. Can is there a real number that we can plug in here so when we square it, we get negative 1? And I can't think of any. We're going to denote this R right here as the set of real numbers. So as you can see here in this particular equation, there is no real solution. Okay, so there had to be a new number system that had to be devised, or I guess you could say invented, that would deal with such equations. So when you square them, you get negative 1. Alright, so what exactly does a complex number look like? Did I say a complex number? Right. So a complex number is in this form right here, a plus bi. This is known as a complex number in the standard form, where a and b are real numbers, right? And I is called the imaginary unit. So a and b, we could label it as this. A and b are elements of R. Okay, and actually this thing here, a plus bi, is an element of the complex number system. Alright, the complex number system. So all the real numbers are contained in R, and you could write it like this. Right, all the real numbers are contained in R. Now, I guess I should state, I guess I should be stating this, that what makes up R is the set of rational numbers and irrational numbers, rational numbers and irrational numbers. We're going to label this as Q here. And then what's contained in Q is Z. So Z is a subset. What is Z? Z is the integers. All the integers are contained in the rational numbers. Right. I didn't say irrational, I just said rational numbers. And then last but not least, this is in the natural numbers, and they're a subset of the integers. The integers are a subset of the rationals, and of course there are irrationals which are contained in actually R here, but all of R is actually contained in C, right? Is a subset of C, and this is the form right here that what a complex number actually looks like. All right, what it looks like. Now the complex numbers are defined. We're going to define the equality, addition, and multiplication in this system, and these are really special properties and operational rules for addition, subtraction, and multiplication, and division will follow. All right. So there you go. Let's just go ahead and what do we want to erase? We'll erase this. How's that? So the best thing to do is just look at some examples. That's what we need to do, is look at some examples. So for example, take for example 4 minus, this is a complex number, 4 minus 2i. Okay, 4 minus 2i, that's a complex number. What about a half? A half plus 5i, that's a complex number. See? So these are all complex numbers, and you're probably asking, well, where do we get? We're going to have to take a complex number and plug it in here so that we get negative 1. right? So that we get -1, and we're going to head off in that direction here in just a second. We're going to head off in that direction here in just a second. So real quick here, I'm just going to write some stuff out. Let's see, so this is known as the imaginary unit. Okay, this is called the imaginary unit, A plus BI, where A and B are elements of R. Alright, this is known, of course, I said, as the complex number. That's called the complex number. Now the imaginary number, A plus BI, the imaginary number, we have to state that B cannot be equal to 0. B cannot be equal to 0. In other words, A can be equal to 0, but B can't be equal to 0. This is known as the imaginary number. The imaginary number. Okay. The pure imaginary number the pure imaginary number is actually, I guess we'll state it like this, 0 plus BI, where B is not equal to 0. They call this the pure imaginary number. Okay, if A is 0, right, and B is not 0, then in other words, for example, like 2i, that would be called the pure imaginary number. Right. And then, of course, the real number is if we have A plus 0 times I. Okay, now basically, where A is not equal to, well, I guess actually I should say that, okay, I said this was the real number. So what I said, this is the real number? Yeah. Where this is actually equal to A. So this is what we've been working with up until this point. We haven't been talking about 0 times I, okay? Which is actually just all equal to A. So we call that the real number. And then of course 0 is just 0 plus 0i, and this is equal to 0. They just call that 0, right? And then here's a real special one, A plus BI. A plus BI, its conjugate, A plus BI has a conjugate, and its conjugate is A minus BI. All right. So that's just some definitions there that we need to deal with. And what we're going to do now is we're going to go ahead and just jump. We're going to jump right in there, working some problems. All right. So let's get started with that. That's just kind of a quick overview on this stuff. And of course, we're going to come back to this. Okay, how do we solve that? How do we solve this equation here? All right. Okay, so the very first problem that we're going to have here is, oh, and by the way, I'm going to attach, let's see if I can bring it up here. And I don't have it at the ready. Yeah, actually, here it is. I'll actually put a link in the video comments section. You can click and see the problem set here. Okay, so this is what we're going to be looking at. It says perform the indicated operations and write in standard form. So we're going to I wonder if I can copy and paste this. It doesn't matter. We'll just write it out. Okay. So this is the problem set that we're going to be going through. Okay, so we have this complex number 3 plus 5i plus 9 minus 7i. Right. And we'll put parentheses around this. There's a reason for these parentheses. Okay, so we've got two complex numbers. We're going to add them together, and what we want to do here is want to get them in this form right here, A plus BI. So that's that standard form that we want to get this stuff in. So what we're going to do here is we're going to go ahead and add the two real parts. So 3 plus 9 is 12, and then the imaginaries, right? So 5 minus 7 is negative 2i, and there you go, it is in standard form. So that's what we wanted to accomplish. All right, so let's take a look at another one. We got negative 1 minus 2i minus 7 plus 2i. Okay, so I'm going to go ahead and drop these parentheses, so nothing much going on over here. But however, here you see this minus sign here. We're going to have to distribute this across. So this becomes minus 7 and minus 2i. All right, see that? So now we go ahead and add the real part. So that's negative 8, and then negative 2i minus 2i is negative 4i. Negative 4i. All right, so there you go. Okay, we're moving right along here. Okay, so we have 2 plus 5i. Now, I think I might have parentheses around this, minus 5i. Yes. Okay. So just drop the parentheses. Right, so as you can see in this complex number, all we've got is the imaginary part, and then minus 5i. So what happens here when we add these together? Well, those are going to cancel out, right? And you're just going to be left with a real number, which is just 2. Okay. So what do we have next? We have 8 minus 5 minus 9i. So we're going to go through 8 minus, distribute the minus across, plus 9i. Add the real part, so we have 3 plus 9i. Okay, 3 plus 9i. Alright, let's, what are we doing here? Okay, I think we're just gonna, okay, I'll have to erase the board here.